Hi, it's Gadget UK here again, back for the final part of the GBA 1000 build. Huge thanks to Conrad Larsen for sending me the PCBs and things. Can't thank you enough. Thanks to Stefan for getting me some of the JEDECs and things we needed earlier on. I couldn't have built this without Stefan's help, for sure. The only outstanding issues here is to try and get it into the case. We've still got a problem with the floppy LED. We have some bad things go wrong as a result of the floppy LED in a bit. Obviously get it into the case, deal with the front panel that came from Dennis Vandenbroek, test a load of things out on this, deal with the power supply, and we've still got this outstanding issue where it fails to load occasionally, WHD load games, and it's like, you know, once out of every several tries something will work and then it won't. And the clock speed on sysinfo is not reported consistently. Same exact screws here. We've just put two in for the moment because I might need to just adjust the plate that holds the drive on the underside. So let's just see how this lines up. Yeah, being careful to try and route these wires. Hang on. The floppy one wants to come here like that. Yeah, that's it. It's just a case of lifting it up and over. So let's just now try ejecting. There we go, that's not bad actually. Yeah, it stuck a little bit there as you can see, but that's not too bad. Yeah, so this first one is the IDE, I think. Hang on, yeah, that one's the power, because it's very short here, just power lead on the left. That's it. And then over here we've got the bodgy floppy LED, which is a wee bit long, but anyway, I'll just leave it that long for the moment. That's that. IDC for the floppy drive wants to go on the back here. That's that. So yeah, that could be, you know, just, I don't know, squashed down. Sometimes folding these just lightly like that in a specific location can help, you know, pull them down. It's got a bit of a crease in that. Remember, this was in the 600 at one point. Yeah, and I think that sort of concludes most of that. I need to secure that drive a bit further yet because there's two more screws to go in. And then we've got this thing here, which I'm going to connect there, like that. And on the other side, up here to the floppy drive. That's it, floppy has power. So we've got one spare of those, and then we've got the one here that goes to fan. That's it. So yeah, I could do with like a cable tie or something, I don't know. The lid's just got to hold this stuff down. You need to be careful that Molex there, what it might connect to. Jumper, for example, I don't want that. So the final thing that's going to probably give me the most grief here, well, other than spraying the plastic panel, is I need to get power switch. Now the power switch I showed you, it's not going to fit, it's too high. So even though the cavity looked like it would fit, it's not going to fit. So I need to sort something out with the power switch. I need to get power in through the holder back there underneath and somehow position this thing. Bear in mind there were no mounts on it. Why couldn't they have designed this with a couple of holes in it or something? Because then you could screw it onto something. So I'm not really sure what to do. I've got the cable that goes with this to route out the back, but I need to do something there. Unless I just have it flying out the back as a fly lead, I could do that, and then cable tie it onto here, stop it getting pulled. But then what do we do with this? Yeah, that's what I'm not sure about. So trying to come up with the most non-intrusive way of mounting this, I've come up with this little slot underneath. You can see I fed a cable tie through, and then I started thinking maybe I could mount it like this. So it's wrapped around the ATX, and if I was to feed it down now straight through a hole, so I think I'm just going to drill a very small hole in the bottom there, and then I can tighten that cable tie, and it's going to hold the ATX connector, which means, you know, you'll disconnect it from this side here. Now in theory, if it's pretty tight, you shouldn't really be able to move it. It should be okay. It'd be very hard to get it out because of the tension of the wires at the back. That's the part where it would pull out of the thing, I think. And I could always just put another cable tie around it in the other orientation. One round here, maybe, I don't know, can't really get it there. I can certainly got one round here. So I think that's what I'm going to go with. It'll still be modular, you'll still be able to unplug this here. Its power input is going to come through the port there. Just for the moment I'll have a fly lead going out the back. But it doesn't mean just drilling a small hole here. I'll have a quick look to make sure there's no print or anything on the underside there, but it's the lesser of different evils really. It's like trying to fit that in there is very difficult. I considered putting it in a box. Well, how do you do it in a box? You can have the point where the red part comes out of here. You could cut a hole or something for that, but then it'd be rattling around in a box. It's going to get hot, it's not going to get air circulation. You could drill holes for air circulation, but then, you know, and I considered this, it will fit in the gap down there like that, you know, all the way flat in front of the fan. I don't know, it just feels like a bodge. Whatever I do, it's going to be a bodge. So I think one hole here and a couple of cable ties, will be nice and tight like that. It's not going to go anywhere. And the beauty with that is, as I say, it'll be detachable from here, and the fan is blowing over here. I will also replace these caps. I'll order some, they're all 220 microfarad. I'll order some hybrid polymers or something, and I'll have to measure up the dimensions, but I am going to replace those because they're RVT. And if you know anything about modern caps, these RVT ones are crap. I recapped that Wonder Mega for Daniela. That had RVTs on it, and it had only been recapped like, I don't know, 12-18 months previously. And I measured the ESR on them, thinking I might be able to reuse one or two of those, you know, for some other project. And every one of them has got ridiculous ESRs. Like, I'm talking like in the tens of ohms, like 10, 20, 30 ohms of resistance of ESR. So yeah, I'm just going to drill, carefully. I'll inspect first, then I'll drill one hole under there. Hi, it's Budget UK here again. Yeah, I've managed to do it in a non-intrusive way without drilling any holes. So yeah, the wires could be routed a bit better here. I don't know. You know, they're going to be a bit close to that fan. But this is secured now. It's just cable tied, so it's cable tied through the board where we didn't have a screw for this because the whole, you know, the plastic is worn there. It's solid. Can't go anywhere. Can't move anywhere. And it's elevated up slightly, so it's going to get some airflow. So I think that's going to be alright. So power switch, still haven't got a solution to that. Just for the moment, I'm going to just route that out the side. But we could do something further with that. I just need to, yeah, have a think, because I'm not really sure what to do with regards to power switch. I could just route the power switch wire down there now I think about it. It's quite nice down there, doesn't it? Yeah, getting you a better angle there, so can you see? That is secure. That ain't going anywhere. It's secured here, it's secured there to hold this in relation to that strap. It's through the gap in the case here, two different cable ties going through there, the one that goes up and round there, and yeah, that's all it is. It's just dead solid. So I would feel comfortable using it that way, even sending it in transit if I sold it at some point. I'm sure it would be okay. Yeah, these wires could be routed a little bit better, couldn't they? They're a bit sticky outy at the moment, but that should be it, I think. So like in terms of powering that, this thing, now if I thought ahead, see, this would have been ideal to go onto there. I don't think I've got a ground point anywhere I could stick that. Get this on. Yeah, this is going to get routed out the back. Hang on, down under there. I really want a cable relief of some sort, you know, strain relief, something, maybe a cable tie around here actually, that point, and that's something that would further secure this. You know, if I had a cable tie around there like that, and just get this at the right position so it's not putting too much stress, it just secures it even further then, doesn't it? But this, there's no other ground points. It's annoying that I can't use that. What I might do is just get some heat shrink around this and extend it all the way down to one of the board points down there. That I think is what I'll do. But I think that's going to be fine. I think let's get a cable tie around that now. And you could argue a cable tie there might be an idea. Yeah, it's still going to get, it still could get pulled, couldn't it? Unless you tie that really tight like that. There we go, that's super tight. That ain't going anywhere. Yeah, my bodging is almost complete, so I extended the wire here with a black wire. Stick enough gauge, it's oops, oh god, where's that gone now? I don't know where that screw went then.
2 hours later.
It took flipping ages to find that screw. So yeah, I've got this thing, hang on, and I've got a washer, and I extended it, and hang on, it's going to go down there. So let's screw that in. So it's just an additional ground point is all that is. Be careful not to over tighten it. There we go. That's nice and stiff now with that washer. So there we go. That concludes the power bodging, and this stuff is solid. It's not going anywhere. Right, as you can see, I've redone this. So it's more secure now. It's not going through the PCB hole here. I've got a screw there. It seems to be a larger thread, actually. There's nothing actually wrong with that hole. I just found a larger thread screw, and it goes in perfectly. And I put cable tie around the actual mount, yeah, and then out here. Got rid of one of the cable ties that was going on the underside, so there's just the one strap holding it there and one holding it that way, and it's really solid. You can, of course, just like bend it marginally to get this out to put the micro ATX in, and it sort of sits naturally into this recess here because of the tightness of those cables. It's held in place. This thing obviously is putting a bit of pressure upwards, so wouldn't have that normally. So that is really solid in there, and it's round the mount. We've got a screw through the board, and we've got our ground strap down here. We've got the power there for the micro ATX mounted onto here. So I think that's going to be okay. I'm just waiting for a new micro ATX. I've ordered one from a different seller. It's got tantalums on it, but it comes with the power supply, you know, the 12-volt power supply, 10 amp. To power it. So once those things arrive, that will complete that. In terms of a power switch, this power switch, it ain't going to do the job. It works, obviously, but it's not going to fit here. So I've ordered like a round one that's, I think, 10mm, which I think I'm going to be able to fit into the gap there. I might need to put something around it, but I suspect I'll be able to have a round power switch, and I've got a white one, just so it's not black like that, it doesn't stand out too much. And I think that will do. I'll show you now how you flash the EEPROM that's on board. So I've got two folders here, GBA1 and GBA2. Yeah, you just double click on this here. If you do find this video entertaining or useful, please do smash the like button down below. And I believe that programs the boot ROM. But you do need to have the jumper switched the right way. Like, is that do anything? Yeah, there we go. That's it. That's all I did. Yeah. So you have the jumper enabled so you can flash it, and then if we switch the jumper over, you know, the other jumper that moves the RAM into the 32-bit Zorro 3 range, then when we reboot, you'll see up here there's like no RAM, and then you have to use addmem, the command line, to, you know, add that memory back in, and we did cover that previously. So I mean, that was it. There's nothing really to show you much really in terms of how you program it up. It's so simple. Right, so I've gone back to booting from the flash ROM with the boot code there, just to put the RAM in the 32-bit Zorro range, and I've got addmem in the start sequence. And you can see the IDE drops to 1.3 meg from 2.7. So I'm going to try adding the mask. There's a mask, and I've never done this before. I'm curious as to how this works, and it says that it could increase, if not put it back in line with the level of performance you had before. I'm sceptical. Maybe it'll do a 32-bit transfer or something. I honestly don't know. I don't know how this works. Hang on a minute. I've got to set that to live.device, haven't I? Just remembered. Icons. Information. Yeah, that's the WinUEE device driver name there. If you want to deal with partitions and things in WinUEE, that's what you need to set there on the tooltips. And it wants to be live.device now. Yeah, the enter key doesn't work very well on this new membrane. It's one of those hard membranes. Ironically, every other key works fine apart from the enter key. Great, these new products, aren't they? The great problems we didn't have with the old ones. So anyway, if we go back in there again, I don't know what I'm doing. Hopefully that'll give us our partitions. Yeah, there we go. And we do partition drive, and then we click on the partition we've got, and then we go advanced options, and then we go change, and the mask here needs changing. Curiously, I've got a really weird mask there that starts with a 7. So it says here, changing the file system mask entry from 00FFFFE. We haven't got a 00, we've got it starts with a 7. That's a bit weird. It says default setting. and it says change it to a C on the end instead of an E, but all Fs. So I don't know why we've got a 7 there. Now I have just backed up this SD card because this may kill it. I don't know what this does. So I'm going to change that to an F first of all. Why it starts with 7 I don't know. And we're going to change that to, I think it said a C, didn't it? What does that do? I don't know. I'm guessing maybe it's the type of RAM. Instead of it putting it in chip RAM, it puts it in fast RAM or something. I don't know. And I'm assuming that's the right place to change it here. Okay. And we need to do the same for the next one. Change. If this doesn't work, as I say, I can just restore from the backup I just took. No, chip RAM's got a priority or something. Save changes. Exit. This power cycle. See what happens. I'm expecting it to no boot, to be honest. I mean, it's taking longer to boot already, that. So that hasn't made really any difference, I would say. Yeah, very little difference there. That is a bit slower, I think. Maybe not, maybe I'm imagining things. Let's just see what that does. It was 1.3 before, wasn't it? I think it's slower. That's made no difference. No difference at all. That is crazy. What's that supposed to do? Because it clearly does nothing. I'm going to change it back now, I think. I don't like changing things that I don't really understand what they're doing. Certainly when they've had no benefit whatsoever. I'm curious to just leave it set that way, actually. Get rid of admem. Cancel, cancel, cancel. I want to see, is there any difference in general performance when it's in the Zorro 2 area? That's, I guess, a worthwhile test before I revert it back. So to do that, I need to go into the startup script again, startup sequence, and comment out the admem, because it won't boot when admem's set if you've in the Zorro, when it's in the Zorro area. You'd think admem would be, like I said this before, intelligent enough to just check is there actually memory there, and if there isn't, just don't do it. I don't know. Yeah, that will cause it to boot fail if that's there when you've got the boot ROM disabled, the flash ROM that is. So I'll switch it off, switch the boot ROM back off. So it's back in the Zorro 2 space. See if it boots. Right, starting to boot. Yeah, so much quicker. It's so much quicker in general already. It's definitely optimised to work Zorro 2, and that's because you've got the DMA, isn't it? This is the thing. So if we look at drives now, that should be back to 2.7 meg, I think. Bear in mind we've got that new mask, of which I don't know what that does. Yeah, 2.769 is back again. Might just leave that mask as it is for the moment. It doesn't seem to be causing me any problems. Maybe it's a bit faster, 2.8 meg almost. The other thing I'm curious about here, and I might just try this, is fit the Live 2 Gotta Go Fast RAM card in the Zorro slot, put this RAM back in the Zorro 3 area, and see if we end up with 16 meg. Well, let's give that a try. They should do, because they're in different areas. And then I can test the IDE speed as well, just to see, does Live 2's RAM give us the super fast DMA with the drive? Because if it does, maybe that's a solution. I might not fit the VGA, you know, the RTG, whatever it is, into this. I might stick a RAM board instead. Right, and I've got Zorro 3 and Zorro 2 RAM, I think. And it seems to be booting, so Live 2 board is hopefully set to 8 meg. Now it's only going to show 8 meg, I think, when we get to the desktop. And that was a little bit slower, so yeah, the Zorro 2 hasn't really made much of an initial difference. This is using Live 2's RAM, definitely. I mean, it seems fast. Let's just see what it comes back at. You see, the thing is with the onboard RAM, it can be addressed 32 bits wide, maybe, I think, and maybe at 50 megahertz. or something close to that, maybe 25 or something, you know, a faster clock domain. Yeah, look, it's even slower now, so using Liv2's RAM, that's even slower. Shows you how you really need that super fast RAM in the Zorro 2 space to get the most out of this machine, really. Well, when it comes to drives, you load software, yeah, it's going to run just as fast as it did before when a program is loaded into that 32-bit RAM. You know, you definitely did have this Achilles heel with the Amiga, you know, the early Amigas there with the Zorro 2. It just wasn't a big enough address space, really. I think what they should have done, they should have brought some sort of DMA functionality in with Zorro 3, where Zorro 3 could do some sort of translation to, you know, do a DMA to Zorro 2 or something. Because, I don't know, I don't even know whether that would be technically possible. Because then you wouldn't have this, maybe this issue. It's the fact that the DMA side of things, which is, you know, Agnes ultimately and Paula and what have you, is limited to the Zorro 2 window there. Let's just do the admin thing anyway. Let's just see if we get 16 meg. Should do, there's no reason why we shouldn't, and then see what performance is like, I guess. Might go back up to what it was, 1.6 meg or whatever. So if we uncomment out admin and escape X, that saves it. Reboot it. Can't do a keyboard reset with this keyboard, it needs a mod. So we should now, in theory, have 16 meg, I think. It's also a valid test just to see, does everything coexist happily like that? I will boot systest in a minute. And or test kit and see. There we go, we've got 16 meg now, look, yay! That's quite cool. I mean, the IDE does feel snappy, but there's definitely a performance drop when you do this bit here, I think. Yeah, that would have come back in a second previously, 1.7 meg. So, you know, it's not bad, it's not bad performance, but you are sacrificing your IDE performance when you move that RAM into the 32-bit range. And if we have a look at memory now, we should have 3 chunks of it. We should have chip fast, so we got, there's the 32-bit fast, and it's at 1, 2, 5 zeros, and it ends at 1, 9 FFF. Why has it got an A there? Yeah, that's after the 19 FFF, isn't it? The upper bound. That's interesting the way that does that. And then they've got the Liv2 in the Zorro 2 range there, where you'd expect it. The same thing, but it's like, you know, put 1 in hex as a leading character less than the other one. So it's, you know, it's 2 5 zeros to 9 F, 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 5 Fs in total. But you can see that's the key here, 24-bit DMA. So you're thinking, well, we've got 24-bit DMA now, why is the IDE slower? It's because it's not 32-bit fast RAM that's in the same clock domain as the CPU. It's in Zorro 2. You know, actual Zorro 2. The Zorro 2, the fast RAM is originally allocated in is 32-bit fast RAM, but it's in the Zorro 2 range. But it's going to run at the clock domain of the, you know, 50 megahertz probably. Or something like that, like I say, it might be 25 or something like that, where that's where you gain when you've got really fast access to your fast RAM. Anyway, at least we know that's technically possible. I am curious as to whether you could add another Zorro device to this though. Like, could we actually get away with sticking the RTG card in there and only having 4 meg on the Liv2? I don't think so, because I think that that's where the lack of arbitration, because we haven't got a buster, is going to be an issue. I think that, like, the slave connections and things that go to the slots, they may be all just like paralleled up or something on these slots, so you can only have one device on one slot. I don't know. And what I mean is, you know, we've got a Zorro slot here, we've got, I think, a Zorro slot here. Originally it probably wouldn't have been, but I think it is. And side note, you wouldn't want your Zorro card like that way up, because the case lid is here. But as I said, there's, you know, a few ways to mount sideways and stuff, and I've, you know, got a few of those parts and things coming to do that. So at this point here, I decided to fix my 40 megahertz crystal, just because we still had the outstanding issue with WHD load would occasionally fail to load something. And in sysinfo, the CPU speed would be variable, it would toggle between 2 different frequencies. I'm sure that was clear as mud there on the microscope. You can see what I did is there were 3 pins missing, so one of them was able to stick into a socket, and then the other 3 you saw me join up with fine wires that, you know, go into the socket pins there, and then I wrapped some very fine single wire, both orientations, and soldered it in the middle so it holds the crystal into its little base, so it has 4 legs. Yeah, and we tested at 40 megahertz. It works at 40 megahertz. The RAM is detected at 40 megahertz. If you saw the previous part, you don't get RAM when you're at 25 megahertz. It just fails to detect it, but it did at 40. But there was no more robust than it was running at 50. And the crazy switch that was on the front, I just pulled that tape off there. Look at the awful solder points on that. It's horrific. Amazing, nothing short there. So yeah, I don't know what this was for. I'm guessing a kickstart switcher, maybe. Something like that. But anyway, I'll just desolder the wire here. And we've got that JST that came floating around the side as well. Was that for the power LED? Was it for something else? I don't know. So yeah, I can reuse that at some point for something. I mean, you could argue that JST, I should have fitted that onto one of the LEDs. And a piece of that switch is broken off there, look, the plastic. Yeah, there we go. That's not too bad. We'll just test it, but anyway, we'll stick its nut back over there, or its washer rather, and the nut can be reused for something else. Yeah, the LEDs on this are weird. I think they're 12 volts. So this is 12 volts, 20 milliamps. I'll switch it on. That's the sort of level of brightness you'd expect. Yeah, not 5 volts or less. And the clue there was when I was looking at the schematics, I was looking at the power LED, I couldn't actually find the floppy LED. I'm guessing on the original drive, there was maybe a cable that came off and went to the LED, perhaps. I couldn't find it on the schematics, I looked everywhere on it. It's just one page that's got the whole of the original A1000 PCB. But on the power LED, the collector, I think, or it might be the emitter, depending on which way the kind of transistor was used, but it was tied to the 12 volt rail, not 5 volts. So in other words, through the transistor, it's switching, or it should be switching the power LED to the 12 volt rail. And that may mean that the actual power LED is not as bright as it should be, but the green over here is the main one that I'm just focusing on, because the power LED is alright actually, even though it might not be as bright as it should be. But nevertheless, that's with 12 volts going there. And it's only pulling 12 milliamps, or is it microamps? It's 0.011 amps. So I think what I need to do is take the motherboard back out, and at the moment where I've got 5 volts going into the pin of the transistor, I forget which it is. You think it's the collector, I don't think it is. I think it's going to the emitter, and I think the collector goes to the positive on this or something like that. I always get confused with anyway, you'll see what I mean. I'm going to swap the 5 volts that's going in for the 12 volts, and I reckon that should then brighten up this LED. It's a bit of a pain because obviously I've got to take the whole board out. Right, so this is the next day. I killed a Gary. I couldn't leave that LED alone, could I? I should have just stuck with it. This is one of those moments that Vince talked about in one of his videos where he was fixing some watches, where when something is, it's almost good enough, but you're just not happy enough, and then you're like, you should have stopped. You should have stopped where you were. Maybe certainly start to reevaluate things before you do anything. And yeah, I killed Gary. I killed, I think, the motor on signal. I think was it pin 47. I mean, that can be recreated. I could recreate that with a flip-flop or two, I think. I had to put a cross on it. Look, it got red hot. It happened twice. It got red hot once and it was alright, and then I did something else and it got red hot again and I switched it off. And it was only for a split second, but that was it. Gone. So now the drive just spins continuously with that Gary, which is a shame. I mean, it really is. I'm gutted. I'm actually gutted. But I mean, I've got another spare. The Gary for this actually came as a separate Gary from somewhere else, so it's like, you know, there's loads of these chips available, but still, I don't like it. I don't like it when custom dies, and that's the first custom I've ever had die from a 500 that isn't a CIA. So this is the thing. So there's like hundreds and thousands of CIAs die. There's loads of garages available. There's tons and tons and tons of them compared to CIAs. But anyway, I'm not justifying breaking original Commodore chips. The point being is the transistor I was using, what I was trying to do, you see, is feed 12 volts into the LED. As soon as you do that, I think you get an effect, you get like leakage through to the base, don't you? So ultimately your base goes higher than it should do. And I think that's got to be the issue, because even though it's buffered, it's not like we connected straight to Gary, we weren't. We were connected to the buffer that goes next to it. But I suspect, well, that's what caused the fault there. I can't quite explain it myself, to be fair. It's something to do with leakage through to the base, I think. And then it must have had some sort of pass-through to the buffer. So in other words, the pin that's actually outputting, 5 volt levels from Gary has somehow got pulled up to 12. That's all I can think. I don't know how. Anyway, so I've now got an N-channel MOSFET there. Its drain is connected through a resistor here to limit current to the buffered signal from Gary. So it's not from Gary, it's from the chip next to it. This should work. It works with other things. I've done it before. It works with things like PICs and Arduinos and stuff like that, so I don't see why it wouldn't work. And the drain is, the LED signal. The positive from the LED goes to 12 volts. The negative of the LED goes through a 150 ohm resistor to the drain. And then the source... Have I got that right around? I think I have, yeah. The source goes to ground. So I'll clean up that in a minute. I'm not going to stick the LED on until I've measured things here. I want to just see what we get. Hopefully not a fire. You see, this is the thing. I was very nervous about dealing with the 12 volt rail, because as soon as you start trying to integrate things on the 5 volt rail with some logic to switch things on the 12 volt rail, bad things happen. Hence the fried Gary. There's no reason why this shouldn't work, but you never know. I could have made a mistake here. I could have wired something wrong, so I don't know. Let's just see what happens. I'm going to put my fingers on top of Gary here. Just switch it on without a drive connected. See if it looks for IDE. Yeah, it's looking for IDE. That's a good sign. Oh, there is a drive connected. Let's just see if it boots from floppy then. Hit an IDE, hit a floppy. Yeah, so I'm lucky I didn't kill anything else other than Gary when we had this issue. For argument's sake, let's say you shorted the 12 volts to your 5 volt rail. Your whole 5 volt rail suddenly, I don't know, increased in voltage or something. Well, you could kill multiple things at once. So, yeah, there's that. But anyway, everything seems alright. Nothing's worse for wear here. As you can see, it's booted up alright. So, yeah, I know I said I was going to measure it. I'm just going to go for it. There is a resistor there limiting current. Let's just connect the floppy LED up. It's a mystery to me how a floppy LED can killing a Gary. It's just what? My wiring must have been horrendous, but it's like I treble checked it. There's nothing wrong with the wiring. Let's just switch it on again. Please work, please work, please work, please work. Yay, it works and it's bright. Did you see that? It works and it's bright and nothing's melting. I finally accomplished it with an N-channel MOSFET. Which, well, that's why I went to an N-channel MOSFET. I had every confidence that should do it. Look, and it does. MOSFETs are great. So there we go, we've finally got the correct brightness LED. I can clean up, I can reassemble it, and all is good. But we are one Gary down. Right, so one of the final parts has arrived, and it's a clip, which I should have ordered at the same time as the battery holder. I'm not quite sure how this clips on. Oh, it's got a little clip on there, on both sides, so I think you sort of just push it over and then down. That's it. Oh wow. Yeah, that's not going to easily let the battery fall out now. You can move it around a little bit. There's a little bit of flexibility to left, right, that bit. I'll switch it on. And I've been away, so it's been a while. I took that battery out while I was away. I was a bit paranoid that battery might burn the house down. Hey, and it booted. Oh, I love this machine so much. Something else I did here, can you see that? it's a little plastic bung for the screw there. I smoothed the ends of the screws down with a Dremel, yeah, the ones that I chopped down in length. But that little rubber bung, it's one of the feet out of an Amiga or a C64 power supply. You know, you pull them out and you never want to stick them back in again because they just block the screw hole. But the point is that is now something that the screw can screw into to hold this firmly. Now, before I smoothed the end of those down, there was a point where, and I didn't show you, the mouse stopped working. It was going in one direction and it wouldn't go the other. And I'm like, oh my god, what's wrong now with the mouse? And it was the screw here, through there, the end of it, because I'd not smoothed it down, and it was touching underneath the board. Two traces just happened to be where the mouse signals come from. And obviously tightening the screw up a little bit, and it just scratched the surface, yeah, and the two traces were shorted. And I know that because, like I said, I took the screw out, suddenly it started working. I'm like, oh, it's that screw. And I took it to pieces and inspected. Yeah, and it's just the solder mask has come off. So I need to get some blue solder mask, I think, and just redo that at some point. The underneath where that screw is there. But anyway, it's shorter now, it's shorter, it's smooth and all the rest of it. But that doesn't have space for one of those rubber bungs because the board is in the way. You'd have to screw it in before you fit the board. And you really need to not have the front on when you fit the board. So you can only get away with having that one rubber thing there, or plastic thing there. But it just holds the front fairly stable without the lid being on. So other finishing things here, I'm not sure if I showed you. I put a clip, plastic clip here, you know, that's stuck down to hold the board, you know, firmly, so it can't sort of rotate and twist. So not only are these two clips here holding it perfectly, you've got the screwed one here in two places and this one here, and it just holds it all really firmly. It's just nice and tidy. Yeah, I can have a shorter cable for the IDE, you know, you don't really need a very long one at all to reach across there. And there's a few different ways you could tap power, you know, because this takes power now from there, you could actually tap power off from here for something, or I could plug this, if this was long enough, I'd plug this one in there, just to make sure I've not got anything floating around. I may try and get some of these, I mentioned before, I may try and get some of these little Molex caps, actually, I'll do that in a minute. Because I've got a few systems where it'd be just beneficial to, you know, cap off any unused Molex. Yeah, so we are nearly there. The only thing I need to do, I'm just going to go do it now, is order a new micro ATX adapter with the power supply to power it. And once that arrives, we can fit the little thing there internally. It's going to be okay secured this way because you can't move, and the little PCB that plugs in is tiny, as you'll see. And I just need to find something to act as a little plate or something for the back under there, for the actual DC barrel, you know, the cable rather, that's going to fly out the back, and then we should be able to clip the lid on, screw it together, and start to use it in its you know, finished glory. Alright, so I've got a 10 amp power supply here, which seems nuts to me, but that's what you get for these Pico power supplies. Yeah, 10 amps. It's like 12 volts, 10 amps. So just going to put this heat shrink over here. It's one of these you know, adapters on the end where you can change the polarity, and I don't want to change the polarity even by accident, which is why I'm heat shrinking this over the, you know, the end piece. It comes off and it's got two prongs and you can plug it in either way round. 10 amps reverse polarity would be a bad idea. I'm nervous about this, if I'm honest. Just because, well, the quality of this little Pico power supply, the caps I don't like, me not like. It's got those RVT caps on there, the marked RVT. And from prior experience, I found that those, they're not the best caps in the world, really. So one thing I may do is recap it myself with some really good brand polymers or hybrids or something. I'll show you the PCB in a sec. I've seen a few of these PCBs where people seem to swap them for tantalums, the electrolytics. So is that a good idea? I don't know. Anything's better than I think the RVT caps that are on it. You can see, you know, it's snugly shaping itself here to the stuff underneath here. I did the same thing on the Falcon because I got exactly the same brand actually for the Falcon of the power supply, and it had the same stupid thing on the end. Why they come like this, I don't know. What's wrong with having a permanently soldered on thing? Why does it need to be an adapted one? I mean, alright, it gives you a bit of flexibility with different types of things you want to connect it to when you can adjust it this way, but yeah, and I have just tested it, centre positive here, and then I tested it to the cable. Yeah, the one we fitted here, and again it's centre positive, translates to the red being positive, and then on this here, when it came to me, I think someone else had written positive there, but you can see it's these RVT caps that may not like you. Anyway, so I'm going to need to now plug this into there, I think. This is the thing. That red plastic is a wee bit sort of slightly cheapish, and it's warped and shaped. There we go, it's gone. So I think now all I need to do is put this on there with this positive in the right place, like that. Just for the moment I've disconnected the end of this, yeah, so we've got the switch going to it, yeah, so I can switch it on. Power supply is on, so I'm now going to plug this into the cable, which is around the back. Here we go, 3, 2, 1. Got a blue LED there. Let's just switch it off. Hang on, where's the switch gone? Switch is here. This is the thing, why is there a blue LED on when it's switched off? It's not filling me full of confidence, this. I don't know. I'm a wee bit nervous about this. Right, let's just test this thing here. We don't have 5 volts. Doesn't matter whether the switch is on or off. I actually think there was this, I need to try and find it. I think there's a cable that goes in here, and I think there's a switch. That's what I think. I think there's a switch. I think this is how you control it. So right now it's not even on. Alright, an unforeseen complication. I've just measured the voltages, they are there. So we've got 5 volts, 5.2, we've got 12 volts, 12.5 roughly, and no, -5. I did wonder about that, but there we go, confirmed. This doesn't produce -5. We need -5 for the sound. Oh god. It's like, I think what I'm going to have to do is go and get 7905, which is a -5 volt regulator, and I think I'm going to budge it on the underside here somewhere. Bear in mind, the -5 is not going to have a very high draw on it, so I don't think it's going to need like like superheat sinking or anything like that. And I could stick it under the board, under this connector here. I could stick it there, but then when you connect an ATX power supply, you're going to have it in parallel. I don't like that. We can power it from the +12. That's certainly high enough. So yeah, let me just work this out now. Got to try and work out where the -5 is. It's on the bottom, isn't it? It's the white one there. I could probably bodge something here underneath to feed the -5 out via the 7905. Alright, having a senior moment here. I was measuring that and I was getting 12 volts, and I'm like, how am I getting 12 volts? And then I remembered, you've got to put a negative supply in, so higher than -5 or lower than. If you think of in terms of a negative, so we need -12. Now, I did just check on the underside of that with another adapter, the other ATX adapter I made, and it is outputting -12. It actually measures about -13. Anyway, that should do. So I've now got 2 extra wires that I took from the original ATX cable here. I've got a black on pin 1 for ground. I've got blue, purple. Oh no, blue for -12, and I'm going to stick these into the adapter there, into unused pins, relevant places, a ground and a -12, and then I'm just going to solder the wire on to where the -5 goes. Now it does mean that I've got a wire sort of permanently attached to the thing that gets detached, if you see what I mean. You know, this wire is going to be soldered onto this PCB here. The other two are going to be on the other side of the connector, so it's a bit of a bodge. And I can get some heat shrink around this. I want to just see though, and maybe even a heat sink. Does it need heat sinking? Probably not. So the ground is the second pin down on this side. So if I was using this adapter, I could just plug that in there, but it's not. It's going to be on this one here. So yeah, I might need to just take this out, this thing here, in order to get this in, actually. And we just need a ground. Stick the ground into there. So it's not connected up to the Amiga, remember, this is the important bit here. And if we put it on volts DC, now all being well, I'd like to see -5 on there now. So we connect the power supply up and switch it on. How have we got -7? Oh God, honestly, going around circles with this. Yeah, so we've now got -7, not -5. I think that regulator's toast. It's warm. Yeah, I think that regulator's toast, so I think I'm going to need to wait for the new 7905s that I've ordered. And there we go. So if I just unplug that, let's just feel this. Stone cold because there's no current draw. -5 volt regulator being fed from the -12 of the Pico PSU. I've got a detachable cable here just to feed it through to the white wire here. And just balancing things, hang on, precariously there, -4.97. So that should be it. The final thing now is to either heat shrink this, stone cold. I'm tempted now though to switch that off, connect this up to the motherboard, like that, power it on and test it with some sound. Finger press this all the while just to make sure it doesn't get absolutely red hot. I suspect it's not going to do, because I think the only thing drawing on that is this op amp. So anyway, let's give it a try. I mean, it is a total pragmatic bodge though, isn't it? This build, as I've said a few times now, has been a build of compromises. It really has. I've had a lot of mixed feelings about this. I'm really happy we are near completion, and we are. I've done the power switch, let me show you. Yes, I swapped out that black one for a white one. I filed the notches off here, filed the notches off here, and then took maybe 1/10 of a millimetre off the top part, the you know, the piece on the case here. So it looks like I've not done anything to it, but when the lid is on, this switch pushes in like that and stays in. It's like it's clipped in by these things on the sides here. And I've tested it, it works. So that's the final thing here. I've just tucked the wires with the cable ties there. They just wedge cut quite nicely, so they're pretty much out of the way. But when assembling it, I'll have the switch out the hole here like this, put the lid on, and then push this in, and it clips in like that and should hold in place. But very near the end now, we're in a situation where we've got a screw in every single hole. Every single screw holds really firmly. Everything is together here. In an ideal world, I'd have an Amiga 1000 power supply here, and then this just would be a non-issue. We wouldn't be able to do any of this craziness with the power supply side. It's in standby. Switch it, hang on, switch the TV on first, I think. So at this point now, I've got to hope this doesn't do something really bad to the motherboard. Yeah, you'll know when I've switched it on, because this fan will start going around here. Let's wait for the TV. Right, 3, 2, 1. Booting. Just looking at IDE. Let's just have a feel of that. Oh my god, that's freezing cold. It's not warm at all. So, let's just launch a game. I just want some sound up. And then when I feel that regulator, I'm just feeling it again, grabbing it. Stone cold. Stone cold. Which is what I suspected. So it's not even going to need heat sinking that. I can just get some heat shrink round it, or mount it somewhere on the board. But it's stone cold. And all is good. Right, I thought about this. I actually think I should just put a piece of heat shrink over it. because you know what, it's stone cold. I've just been using it for like 10 minutes and it's just stone cold, which, well, you'd imagine it would be when it's in the path of the, I mean, it's obviously going to get warmer with that on. I actually think that's just going to help dissipate the heat. I'm going to shrink that over there like that. Hopefully it'll hold in place. If it was on any other rail on here, I would be highly concerned. See, the current draw on that is going to be so low. We're talking like 50 milliamps, 100 milliamps or something. That's it, that ain't going anywhere. And it is right in the way of the airflow, even if it did just, you know, get a few, I mean, it's hot now, it's red hot. It's right in the path of the airflow here though. I mean, in theory it could go and drag on the fan. It's not going to do, is it? And as I say, I've got a detachable wire here, so I can actually unplug this, detach that, and the little module comes out. So, and everything's heat shrunk there. There's no chance that's ever going to be a problem. And the heat shrink's pretty tight there, so, you know, those things are going to hold in place. So we are, I think, now at the end, which is, well, a miracle. An absolute miracle. So I'm just going to wait for that to cool down a bit before I power it on, just because of the fact I've heated it up. So I need to burn-in test it. You can see the -5 volts spot on, and yeah, this is directly in the flow of air here. It's cold, it's stone cold, that, because there is just that op-amp drawing on it, nothing else. Trail the power switch out the left side here. Yeah, it's that moment, it's the moment of completion where I can carefully just try and get the lid aligned on the left side here. This is where the clips are good, or were, before I start trying to get the lid back on. That's it, and then push the front into place like that, because you've got holes there that line up, and then try and get this side here lined up. Yeah, easier said than done. There we go, that's on. That side is on. I'll push the power switch in at the end. That's just disconnects all these things. And the lid's come out pretty good. It just needs a bit of a polish on the top, but most of the marks came off there. There are a couple here that maybe need polishing out still. So yeah, this side could be a bit more problematic, because I think the clips are maybe too high up. I don't know. Like, hang on, that side's okay, I think. This side here, I'm not sure about. See, it's been a bit of a pain, this one. Yeah, I actually think that this here is too low down. It needs bending up, which I can do because it's metal. Let's try that. I'm not really sure why it's sticking here in this corner. Ah, there we go. Wow, that's pretty tight as well. So, straighten it up, hang on. Need to turn it upside down. Hopefully nothing falls out when I do this, or falls out of place. Yeah, it's got some nasty scratches on the underside, this, but well, it was really beat up, wasn't it? And you could argue it'd be nice with like a 3D printed plate here for this wire, but it's secured in with 2 cable ties there, so you know what, I'm not worried about having a cable out the back there. You know, it could sort of sit under the back or down the wall or wherever. So I just need to get the remaining screws in, which I think, yeah, I got them ready earlier. So again, Amiga 500/600 screws that are the same size from one of the service manuals. So yeah, I apologise, I can't remember what I ordered, but I went searching through 500/600 schematics, you know, service manuals, and ordered screws exactly the same size. So if we start with that middle one down there. The downside to these is they are not magnetic. that screw's gone now. Clearly not into the right place. Let's try another one. Oh. Now that one's going in. Nice and tight. Not too tight. Let's try the next one. That one's going in. Nice and tight. Not too tight. And that's it. You don't have to turn them very tight. Or very far, in fact. So let's put this on here. So I do have the cover here that we got from Dennis, and I've got some paint, so we'll perhaps do that bit next as a final. And you can see what I'm going for with the power switch here. So this now just goes there like that. Isn't that perfect? I like the colour as well. I'm glad I went white instead of black. I do need to clean the bottom half of the case up. There's fingerprints and marks and things. So I'll get some plastic cleaner on there. Maybe the front edge of this here as well. It's a bit dirty. But that should be it. We should now have a complete system. It boots really quick. I'm talking like in less than about 7 seconds or something. And I guess now we've got the lid on, it would be a good idea to test the floppy drive. You can see there's no chance that's going to get smashed off, is there? So let's try this. I knew you were going to have to push it in a long way, but look, you can eject it. And my floppy LEDs are working fine. So let's just power cycle that just to boot from a test kit. And I need to plug the mouse in, don't I? Hey. Fantastic. I'm curious to see if the time date has been held. I can't remember whether I set it actually, because I did take the battery out at some point when I was away. Yeah, that's right. 17:49 on the TV, 18th of June. So all is good. Fantastic. It's just to test the audio. Oh yes. Sounds great with that bird brown op amp as well. Thanks for Xavier for giving me the idea of using that. Intended for the Archimedes, but it's coming to this Amiga. Let's test the filter. You can't really hear the filter very well on this, I have to admit. It's probably that bird brown op amp. Yeah, I can hear that. Yeah, I can hear that. I've got to use my right ear. Bear in mind, I'm still getting over COVID. Yeah, and if we eject the disc, you can see you do need to push in to that cavity. But I'm alright, I've got fairly dainty fingers for a guy, really. Right, let's power cycle it. And if we just power it back on again, should hopefully boot from hard disk. Lovely LED there, thanks to Colin and Nathan originally. Alice and Chalices. Love it. And yeah, so we got this. We'll paint this in a minute. So, hang on, which way up does this go now? It goes that way, doesn't it? So I did micro adjust this earlier with files, as Dennis suggested it might be required. You can see it's pretty tight now the lid's on. There we go, that's going to be fine, isn't it? I think you'll agree, that's pretty blooming good. Well done, Dennis, that is just incredible. Such a good fit. Now bear in mind you've got little clips that could clip there and hold it a bit further on the front. I don't think I'm going to stick those clips on. I quite like the fact that it's fairly easy to get off and on. I'm not sure whether my paint is going to be the right colour. This is the thing, I went with RAL 9001. So yeah, we'll give that a go and see what that looks like. But already I'm just happy as things are. I'm just happy with that. I really am. You know, stepping back a bit there, looks pretty blooming good. And you know what a crazy thought I did just have? There is enough space in there to fit this in there. You could literally have this power supply in there and have, I don't know, extension to the mains lead coming out the back instead of what we've got. But that's just going to add heat, isn't it? It's better if it's outside the unit. It's easily replaceable as well. Right, this is the following day. This did not go according to plan. Shook the tin. Yeah, for a good minute or so, and then proceeded to spray, and it went blobby everywhere, like really heavy blobs over the whole thing. So not only is the colour not right, and you can see, you know, it's like too whitey. Can you see how patchy it is? Look at this here, it's like really thick, and here it's bumpy. Yeah, it did not spray, it didn't come out as I wanted. Now I only did like one hang on, oh god, it's all gone blobby, and that was it. So I tried to wipe it off, it already got dried already, it gone solid instantly. I can't believe how quick it dried. So I've left it overnight and I just started sanding it, and you can see I managed to get lots of it off here. There's some patches still. What a nightmare this is. It's not easy to sand either. I thought this would be really easy to sand, but it isn't. I've got two different grits of sandpaper here. I've got really thick stuff, and this is the stuff that seems to be needed to get these lumps off. Well, a testament to whatever Dennis 3D printed this in, all of the marks you can see, you know, paint blobs, they're coming off. It's like you can just literally just go forwards or backwards a little bit, and maybe it's because the paint's not really set and I didn't put very much on, so just these little blobs. It's coming off. This is actually paint stuck on here, and there's very little scratching. There is some, but you know, I can use the fine sandpaper to smooth that out. I might even just put it on white. I don't know whether I can be fussed to keep going around this cycle if it all goes wrong again. Right, I think we're back to pretty much a level playing field. That took me ages. You can see it looks a bit scuffed and stuff, but it is very smooth. I'm going to wet sand it now, so I'm just going to add a wee bit of water there like that. Get a fresh bit of sandpaper. And I don't know whether wet sanding is a thing with 3D printed plastics like this, I don't know. I mean, I don't even know what kind of 3D plastic, you know, not 3D plastic, but plastic this is. I have no idea. You know, I'm almost tempted to just stick it on it as it is. I said this before. I don't know whether I can face trying to paint it again. Yeah, that's come out remarkably well. I think if I wet sanded a bit more at the top there, I'd have the same sort of like really smooth satin finish I've got there. Do you know what? I don't think I'm going to paint it. I think I'm just going to stick that on. So as you can see, I've set it up here. I think I'm going to move it. I don't like where it is. Obviously there's a lot of weight on it from the 4000. Sounds great, it really does. I switched the audio switch over, I had Turrican on the 2000 room, and I prefer the sound coming out of the GBA 1000 if I'm honest. But I need to adjust the VGA, I'll show you, hang on, just power cycle it. So we're using the VGA screen that I showed in the previous video here with the adapter on the 2000, but it's not using the adapter on the 1000, we don't need the VGA adapter, it's using, you know, amber, straight out of amber. See the lines? So no amount of adjustment there, I can get rid of those lines. This shows that actually the trim cap and the resistor in there need an adjustment, which is a pain, isn't it, when the 4000 is on top of it. And obviously I want to prototype the replacement of amber. While this is on here, it means it's really difficult trying to get things into the 2000. It means the 4000's a pain in the bum as well. So it's like, I think I'm going to take this out of here and I'm going to put this under my 1200 in the other room where I can use this on a fairly frequent basis, because this has got, well, it will have an RTG in it at some point when we build that, and the 1200 hasn't got that. The 1200's got AGA, this hasn't, and then I've got the best of both worlds. In there I'll have something that'll have a Zorro slot, you know, an RTG, and the 1200 on top of it. The 1200 should fit nicely on top of the GBA 1000. It's a bit easier to move things around, get things in and out and stuff when you've only got a 1200 on top of it. And maybe get a keyboard for it at some point that will fit underneath it. Not sure about that yet, but it just means that the 4000 on here, yeah, it's still a bit of a pain when the 4000 is on top of the 2000, but beggars can't be choosers, so don't have masses of space. So I'm now going to undo my hard work and put this in the other room. Right, here we are outside. This is take 2. This was the first attempt. Can you see how blobby it was with a different spray? So I've got this. Now I don't like the colour of the lid there, that looks really cream, doesn't it? But, well, I don't know, maybe it's going to be alright. right, I've given this a pretty good shake for a minute or two. Now this is what I did last time we did the spray, and of course it just went blobby. So I've used this brand before with black and it's been alright. So let's just see, let's just try and move this up there a little bit. Let's just spray there, hang on. It's looking very yellow, isn't it? Yeah, I'm going to leave it like that to dry, put the lid back on here and give it another coat in a bit. It's looking very yellowed plastic. So as you can see, I've been using a different paint on this. I'll show you the RAL coat. Can you see how that's yellow? Yeah, the colour I was using, that cream, was making it really, really yellow. So yeah, I'm giving it a go with a different paint here. It's this here, RAL 9001. It's still a cream, but it's a lot lighter, so yeah, it's not going to match, but... So after several coats of the other paint, the crazy thing with this, right, it looks alright, doesn't it? I think. Yeah, this is going to be the top. It looks alright. Maybe this side's a bit darker than the front. There's a slight cream hint to it. Look at the inside. It doesn't look any different to the plastic. I should have just left it. Although I'm sure it was like super white. Maybe it was. Maybe they just got some paint on it, I think. It must have. It must have had some overspray or something. But yeah, anyway, that's the end result. So it looks great, I think. But it's a different colour to the plastic. Trying to match plastic is just impossible. I tried various, 2 different RAL codes there. Both of them suggested by other people on forums and things that they use to paint their 1000. With aging of plastics and things, you always get, variations in the colours and things and manufacture. They didn't all come from the same place. I actually think the plastic pieces were manufactured in at least 2 or 3 different factories. And just as a bit of an extra here, because we don't have a full A1000, I can't show you the motherboard. Vincent Price on the Discord kindly offered to share these photos of his A1000. You can see he's got a tower of 3 of them here. It's incredible. Slight variations between the different models he's got, I think, from different points in manufacturing, I think. And you can see some close-ups of the motherboard and the daughter board that goes with that. The original 1000 would have had only 256k of RAM on board, and kickstart was loaded from disk. Yeah, you switched the machine on, you had no kickstart. Yeah, you had to stick a disc in, and then you had kickstart. Then you could stick your workbench disc in, and you'd only have 256k for that. And I think the kickstart was stored in RAM on the board. There might be 256k or 512k of RAM on the daughter board that allows the ROM to be loaded into some of the RAM. That it uses as ROM. It's strange how they implemented it to start with. And of course, that old revision motherboard had the initial Agnes there, the dip Agnes, just like we covered on Conrad's 2000. And he's got some photos here of 1 or 2 of his upgrades and things that he's got for his 1000s as well. Very cool. Thank you very much to Vincent for sharing those with me and with you. Right, so I'm going to fit a 100 MHz crystal here. Not to run it at 100, but to set the resistor in the lower position here and divide by 2 to get 50. The clock that comes out of this area here goes to both of these, so it's not like I thought in an earlier part, like part 1 or part 2, I think, where it just goes to the FPU. It doesn't. George did this to deal with the duty cycle on the crystal. So this 48 MHz one at the moment is stable. 50 is kind of glitchy, but I think with 100 divided by 2 giving us 50, with the correct duty cycle, it shouldn't glitch and it should run at 50. So that's the theory anyway. Now, when I fitted this, I think I fitted a socket with all of the relevant pins here. Pin 1's bottom left there. Yeah, that's right. And I think it's going to be aligned like... Hang on, I can't get the darn thing in there. I think the legs need cutting down actually, they're very long. There we go. That should be it. So I'll stick a cable tie back around it once I've proven it works. But the other thing I need to do is move that resistor to the other position. Now I could take the board out, use hot air, etc. I'm just going to try and heat it and move the tweezers. that should have been like a 5-second job, I think, if I'd been able to get better access to the board. Anyway, let's clean around it. But I mean, the pads are alright. I've just made it look difficult, is the thing, really. Yeah, it's slightly raised on one side because one or two of the pins need cutting down. It was the wrong way. When it's in the position up here, it wasn't doing anything. But it has booted, look, so the thing is now, I need to test for stability. Let's get it to mouse up. So if we do speed test now, it should be... Well, we shouldn't see 48 is the thing. It might be dip a bit when it's doing stuff with interrupts, I don't know. 51.8, look. So I guess only time's going to tell. What I really should do now is reassemble it and test it for a bit. Just a few tests here. 51.8. I expected it to drop a little bit somewhere, but seemingly not. Yeah, that may explain why we had some variation in clock speed before, because of the duty cycle. Maybe it was like just playing up a little bit. Occasionally going slightly slower, occasionally going slightly faster. Now though, it's solid at 51.8. If you remember previous videos where I benchmarked it, it was toggling between two speeds. So I think that's the case. I think we had some jitter or something, and the duty cycle not being right was making it a little bit variable. You know, 1 minute it's 48, no it's not, now it's 50, no it's 48, then it's 50. Whereas with this crystal, we just seem to have solid 51.8, so I'm going to call it at that and say that that's probably resolved it. I do wonder if that's going to solve the IDE issue, actually. Yeah, and I appreciate just going in and out of a few games is not really going to be conclusive testing, so I will need to get this all back together in a minute, test for a period of time, and then report back. Let's just try loading something from here. I don't know, let's try something else. Because that one's not got the thing in the same folder, the executable. Let's just try Gallagher. Yeah, it's there, look. I'm looking for the one without the E set. So it's not executable, I think it's a script, isn't it? But yeah, it's there. It's there. Maybe we've solved it. It's there. Yeah, I'm going to report back, but right now it just seems better. It seems better with that crystal. Yeah, it's there every time at the moment. I'm just going to trim one of the legs here down because, well, it's sticking up. So let's just pull that out. Yeah, get that back in. That's it. Yeah, cable tie it back in as well. Just by getting the cable tie under there. Hang on, I can't reach the cable tie now. Like that. Just double check it. Yeah, that's nice and firm. So I can now get the drive back in there. But anyway, let's just try this out for size now. It had some slight tweaks done to it when I received it, you know, filed like the edges and things, but let's just see. And I haven't got these two clips. There's one that go on the top of it, one that go on the bottom of it. They're just taped there for the moment. And what I may do is just tape them on the inside of it. Yeah, you could see it probably does need something because it doesn't really stay totally flat and flush there, but yeah, and it doesn't really fit the colour, does it? It isn't the same at all, but it's better than it was because it was bright white. Now it's kind of thick white, like yellowy white. That's alright though, I'm happy with that. Massive, massive thanks to Dennis for 3D printing that. Both of these have the same issue. They both behave exactly the same. One at 50 megahertz, one at 100. It's just that divide by 2 that is, you know, evening out the duty cycle. You know, it's either on or off for equal amounts of time. But in both instances, if we scoped these, I mean, we may see the positive pulse slightly higher than the negative pulse, and it's probably about where it's actually triggering. You could argue that if these were, if you know, you had a Schmidt or something on the edge of the clock before it goes into wherever, maybe that would solve it. So I honestly don't know. It could be that where these clocks are going is the nature of the problem. In other words, if they're going into the 50 megahertz, you know, the lattice chip there, maybe that's triggering in some sort of way slightly inaccurately on the edge Yeah, so the edge is slightly moving around, and I think this is creating jitter, which I think ultimately is why this is a solution using the 74 AC. I think it's an AC. Was it AS 74 AS 74? So what I did here is I pushed one of these clips in, yeah, until it hooks on the inside on the lid. There's a little notch up here, and you can feel there's no movement. As soon as I did that, I drew a little line and worked out the distance when this is on. Are they about the same? They are. So I was able to just literally push this right to the bottom, put a tiny dot of super glue there. So that's fairly well secured now. I'm not going to stick both on because the bottom clips on really well. You've got to sort of get the top part in first, otherwise you'd break it off, and then just ease it gradually in like this, and hopefully it won't break. One side, the other, and it'll clip up here. Now, there you go, did you hear that? So the lid is now holding it there, which means when that's pushed into place like that, it's pretty perfect. Yeah, there are some, minor differences. It looks a bit wider there. It's ever so subtle though. It's pretty much perfect. Dennis has done an incredible job of precision 3D printing that. Anyway, I'm very, very, very pleased. So I think the other clip, I'll just tape it somewhere on the inside of this, just so it's got both clips, but I'm not going to stick both on. If I had both clips on, you've got to sort of push them in as you pull it out. You could remove the lid, that makes it easier. But now I can literally just pull the bottom clips and tilt it so that this clip here goes like that and unclips, if you see what I mean. So it's better for me to just have one clip in place, I think. Yeah, you can see I've just taped that inside there. The colour on the inside is not very dissimilar to the outside, is it? But bear in mind, it did go really creamy at one point. So yeah, the painting was a complete waste of my time. It really was. And this case is obviously, there's little yellow marks on it. I've polished and polished and polished it. It's as good as it's going to get, basically. Clip. I really like that reassuring clip it does. Yeah, that's it. And there we have it, filmed an incredibly long time later. There's a little mark materialised there because it's been sat out of the way. A little bit yellowed here. There are a couple of scratches that show up in the light, but I think you'll agree, it's come out blooming good, really, all things considered. If I show you on the underside here, you can see there are some scratches. It's quite heavy, this. Some big scratches. Got one there and one there, that the permanent, permanent deep scratches. You can see one of the cable ties on the underside there. That's basically how the power supply's fitted in there. But everything's there, the badge is there, didn't have to put any holes in it. You can see around the back here, I'm leaving those gender changes there. The audio sockets are okay, fan holes in place. It's really, really nice. I am so pleased with the way this came out. If I just put that back down. The one thing I would say is the power cable that comes out the back here, if there was some way, if I had a 3D printer, I could have printed like a bevel or something, an insert that goes in that hole on the underside there and route the cable through it. But it's cable tied on the inside in a few places, so you can't pull it out. You can see I've just plugged the keyboard adapter in there, so let's use this keyboard. I'll try and get a proper keyboard for it at some point. But this is the one I created, the behind top right, for my 2000, but it gets shared with my 4000. I kind of swap between the 2000 and the 4000 with this keyboard. Not always, depends whether I need a keyboard connected. For most stuff you don't, but there are some, obviously, games and apps where you really need a keyboard. It is a bit dusty, I need to hoover that. Let's switch it on. Yeah, power light is on. Hard disk flashing. So we've got our 8GB RAM, 2GB chip, and the mouse is working, and it runs really quick using LIDE. So massive thanks to Live2 for the LIDE driver that we're using with this, and it now runs a solid, stable 50 megahertz. If I do a speed test here, what we don't get is the bobbing around like it was doing before. It's got like 48 point something, 51 point something, 48 point something, 51 point something. That's solidified when we used 100 megahertz crystal with the jumper there, to go through the divide by 2 to get the 50 megahertz that way. Yeah, full 68030. Yeah, we do have the 50 FPU running at 50 there. Yeah, I think I went and found one that ran at 50. So if we switch the co-processor tests on here, it's 3 of them. Yeah, there we go. We do beach ball. Yeah, there we go. And that's working. That's working fairly reliably. Well, reliably as far as I can see, at 50. Fantastic. But anyway, what I was trying to say there is the benchmarks here on everything, including the MEM test one, I think, comes out faster than it does on the 534. Yeah, 19. It's like we're right up here. 18.69 is the actual value, and that's something I never noticed. I always use this to try and work out where it is in the chart, but it actually tells you there when it's in the U column. The CUPE rates. Very cool. So just showing you the TF534 performance, because you know what, it gives really good performance to the 534. It's probably not dissimilar to the 536. So you can see we've got less MIPS there, 10.34, 9914. Chip speed's a bit faster here actually, I'm wrong about that. It's slower on the GBA 1000. And the same clock speed exactly, 51.8 megahertz there. So full 68030. And if we do a MEM test here, yeah, you can see we're lower. Now this is really fast in my mind. I mean, look at it compared to 4040. The 534 and the 536 may be slightly faster than this, I don't know, can't remember. But we got 12.99 there. One other point here, this hasn't been used for about 4 or 5 months, and the battery, let's just have a look at the time of day. If we're going to, there we go, 20th of the 1st, 25, 1438, and you can see down there 1440. So it's a couple of minutes out, but it's been 6 months running on that battery, and it works fine. That's the thing with using an ultra-fire battery like that, isn't it? It's got such high capacity. You could not use it for a few years, and I'm sure it would hold the time and date settings, which is just incredible. But that's a bit of an Achilles heel on this. Not really an Achilles heel, a risk, you know, the way I drilled through multi-layers and then the way I isolated. Yeah, there's a kind of chance that at some point with a pretty nasty knock, maybe in transit, if it's ever sold, the battery could short. But would it cause a problem with the battery? I don't think it would. I actually think the system just wouldn't boot because the ground and 5-volt rail would be shorted, so you wouldn't be able to power it on if there was a problem with that. You know, the drilling the hole there. So certainly be careful drilling multi-layer PCBs. Don't do as I do. I'm good at doing that, and I'm saying don't do this. Get protection for this. Wear eye goggles, wear gloves when I've not got gloves and goggles on. A lot of the time I do though. You don't always see it. Next time I've got goggles on, I'll show you. The thing that can make something like this difficult to build is, well, firstly, obtaining all the parts, certainly. The amber, just on obtanium. I will, again, when time permits, I need to get things off the bench still first, go back to the replacement amber that I was working on and see if we can find a, you know, a CPLD replacement for that, create one. So obtaining the parts can be quite hard. And in terms of the bill of materials, you really need to look at the schematics when you come across something that just doesn't make sense. You know, we had a lot of typos on the bill of materials where the part numbers were just, you know, the sizings were a bit cryptic. You know, like R33, R2, for example, it's just a 33 ohm. And there are a few like that. There's 5 or 6 different components where you're like, I'm not really sure what part they mean there, that's a weird size. Like 90, there was one 90 ohm, wasn't there? 91.3 ohm or something. You can't get that. It's just 91 ohm or thereabouts. And I think even I didn't get the exact size, or somewhat like 90 ohm or something, and it was fine. The video's, you know, quality's superb, the audio quality's superb. Works out really nice with the Burr Brown op amp. It gives it its own distinct, I'm playing awful with this, I'm not Jamie Morgan. It gives it its own distinct sound, you know. It sounds a little bit different to the other Amigas, and it does anyway because of the way George designed the circuit there. You can argue more optimally. It does give a really clear, crystal clear sound output, but the frequency response is different. And obviously it's got a filter, whereas I think the original 1000 didn't have a filter. It's interesting, he took the approach of adding some features to bring it more in line with other systems and usability and stuff, but then when it came to the serial power ports, he went with the original crazy, you know, inverted gender issue. So, you know, that's a bit of an oversight if you ask me. You may have fixed that on the later version 5 and onwards boards, I don't know, because I think there were 2 more boards after this. One of them was the final revision of this board, but then one had the 060 card built in, I think. I could be wrong, there might just be one revision more, it might be the R5, and that may contain the 060/040 card built in. And I think at that point he consolidated the logic. So instead of having all the gals you've got on here, I think you may have just used a couple of lattice chips or something to support the, you know, the expansion of the 060, but also the consolidation of the, you know, some of the gals, so that you don't have so many gals on there. I could be wrong. I'd need to look at one of those boards, so we might do that one day. I don't know. We've certainly got a bunch of expansion boards to look at in upcoming videos, I think. Post down below, what do you think I should do next? Do you think I should have a look at the RTG card? Do you think I should have a look at the 32 meg RAM board, or should I go straight for the 060 with RAM? Or the actual, is it the Fileline, I think it's called, USB Zorro card, which should fit in the front slot, I think. Yeah, let me know what your thoughts are. Each one of them is going to have its own challenges. I've managed to get the code thanks to a guy, I'll stick his name top left. He's provided me the JEDEX and the Gerbers and things like that for some of those things, so we should be able to make some progress with them. It's just going to be another one of those, it could be a bit difficult tracing, you know, or chasing parts, trying to find specific lattice CPLDs. It isn't that easy, and some of the RAM is a bit hard to find these days. The Amber's impossible to find. Most of the other chips, it's just off the shelf stuff. 1 or 2 of the 74 series is a wee bit hard to find. There was that one on the IDE that took me right to the last minute to try and find the magnitude comparator. I think it's got open collector output or something on it. So that was a bit fiddly to find. But the RAM, the RAM for the you know, the fast RAM. I think you need, is it 16 of those chips? I'm sure it is, and I ordered 20, so I have 4 of them spare should any one cause me an issue. If any more than one fails, obviously I'm going to be totally knackered. Yeah, so that can be quite hard to find, that RAM, and it's very expensive. I think I paid something like £70 or £80 for that RAM, which is crazy. The 2 meg of chip RAM, it's the style of chips you get on Sims and lots of other things. The A570, I've got one of those coming up soon thanks to Sparks UK. I bought that from him. The CD-ROM drive you get for the Amiga, the RAM upgrade for that uses exactly the same style RAM chips as the chip RAM on here, so that's a bit easier to source. But again, there's very few places selling it, so in a year or 2 I wouldn't be surprised if you can't find it. So yeah, it's getting harder and harder and harder to build something like this, to be honest, and I think it's a minor miracle that I pulled it off, considering this project's been around since 2007, 2008, I think. I mean, the revisions would have been done, you know, 2-3 years later, but we're still, you know, we're in 2024 now. You know, 2007, 2024, this is an old project in its own right, isn't it? It's an old system. Not quite as old as the 1000. So a huge thanks to Sparks UK for some of the bits that I used in this, namely the Agnes that featured on my Vince's channel when I fixed the legs on it. Stuck 5 or 6, maybe 4 or 5, I don't know, legs on it because it was completely missing. It was so corroded. It was kind of bin fodder, and I thought that was a nice place to leave this ultimately. Put this in this machine. It's got lots of bits from everywhere. It's got the Atari heatsink clips, you know, to hold the chips in, which is quite strange, a strange choice, but I think it's quite cool. Thanks to, I think it was Andrew Littleboy for the IDE board in this. So you saw the issues I had mounting that in there with different clips and things, and it took me quite a while to get all the clips and things in place until I've ended up with the way you saw it towards the back end of this video here, where it sits in place perfectly. Only held in with 1 screw, but clipped all the way around and held in place securely. That PCB came from Andrew Littleboy. It was thrown in, I think, with the Archimedes Scion, you know, the Acorn branded Scion that was designed to go with the Archimedes. So a massive thanks to him. And I'm sure there's probably other bits that I'm forgetting of. Obviously the front panel from Dennis Vandenbroek there, it's came out really well, that. I'm disappointed that I couldn't colour match it. You saw the shenanigans I had with that. It's like, we ended up with it not dissimilar to its original colour. It was a bit whiter, it was more like that white. So there's a cream sort of colour to it. It's the best I could do, I just gave up. This is kind of like a grey green, isn't it? So it's slightly aged, but what it isn't is the same colour as my 2000, but it isn't the same colour as the 4000. Yeah, and I mentioned Stefan a few times. There's no way I could have finished this off without Stefan's help, because, well, I couldn't find the code for that lattice chip anywhere. It's not on any of the public forums as you know, a publicly available thing. I think following this video I'll upload the files that I have onto the Internet Archive. I'll see if I can speak to Georg Braun first, if I can make contact with him. He's probably knocking around on one of the forums somewhere, and get his permission. Say, can I upload this to the Internet Archive, all the files I have? Are you happy with that? If he's not, then, well, I don't know. I can only respect his wishes, really. And yeah, you could always ask me if you need them for something, and, well, I'll hand them over unofficially to you so you can, you know, program up a board. But I don't know what the secret would be and why George wouldn't allow me to do that. But anyway, I'll put a comment. I guess I'll update you in a minute as to the state of affairs with that. Yeah, fond memories of playing this game as a kid. I initially played this on the Atari ST, and I got that quick shot pedals you could get, and it was like different coloured pedals. It was like a red one, a green one, a blue one, a yellow one, or something. And you could use them in a game like this, and you could change the configuration of it. So, like, you know, you could choose, you know, like, what does the first pedal do? It goes up, and the next one goes back. So you could have accelerate, brake, one for a clutch or something. And I had a steering wheel and everything, and I used to play that on the ST. And then that carried forward to the Amiga version, until eventually, I think I got rid of those things, actually, the pedals and what have you. Just noticed the spacebar on this keyboard is not very straight. You're probably getting sick of hearing me saying this, but yeah, I'm using the Mega Multi again from James at Retro HQ. So cool. This is the prototype one, actually. I've got manual, haven't I? Manual gears. Short gear in a minute, yeah? I'm in 6th, aren't I? It's quite hard. Downshift, you know. I can't get the words out. Downshift. You've got to be pressing backwards and then press the gear thing. I can't go down the gear. It's so cool, the engine for this. This actually featured on the Mega Drive, didn't it? It went into one of the racing games on the Mega Drive, a couple of them actually. I think one of them was a bike racing. So it goes without saying that the 2000 is a much better prospect versus building one of these. I think if you had the choice of building an Amiga yourself, and it was a choice between the E80X 2000 and this, the E80X 2000 just makes so much more sense. Because, well, A, it's an E80X design, you can put it in a, you know, E80X case and use a regular power supply for it. And you've got loads of Zorro slots. Yeah, you're lacking amber, and I think that's what appealed to me when I first saw this. I was like, wow, it's like a 3000, it's got amber on there. Amber's like really exciting if you've never had, you know, a de-interlacer like that. But there are cards that do the same kind of thing. We've covered some of those, like the AGA Multifix. So you're left with the, you know, the thought that what's the point in something like this when you can have an E80X 2000, just put, you know, a different scan doubler in there, is the point. Yeah, I just ran straight off. I do too much thinking rather than playing. And obviously you've got a lot more space in a 2000, not just in terms of the Zorro cards, but for, you know, space for drives and other upgrades and things were really limited in this machine. I would have much sooner, personally, had an actual Amiga 1000 motherboard in here. If I'm honest, alright, it's nowhere near as capable in terms of the upgrades we have built in and what we can still fit in upcoming videos. But it is quite limited, isn't it? Yeah, there are some pretty severe limitations with this. I'll switch that off. And the costs involved. Now, I didn't purchase the PCB. That's a massive, massive, massive thanks. And again, this video wouldn't be possible without the donation from Conrad Larsen for the board and the daughter boards that we've still, yet to look at. But when you take into account the cost of the case, that was something like £240, I think. I think there may have even been import tax of like £30 or £40 on it as well. All on the way to £300 for a case, which was crazy. Because you know what, I've seen fully assembled 1000 sell for like £400 to £500. So should I have just bought one with a motherboard and a power supply and everything? I don't know. But then you're back to the limitations of the 1000. This is so much above and beyond the original 1000. So it kind of did make sense to get this rather than an actual 1000, because I think whilst it may have made more sentimental sense to me, I think I still would have been a bit put off thinking, well, it's quite limited, isn't it, the 1000? You can't really do much. I'm knackered with chip RAM, I'm knackered with the Agnes, and I haven't got much space inside. I haven't got any Zorro slots, really, So there's all of those things to take into account. But coming back to costs again, if we say argument's sake £300 for the case, that 3D printed by Dennis, if I'd have done that myself, it would have been 20 or 30 quid, plus paint, and then all the parts that I got, I would estimate around the £400 mark in general. And that was with some really good deals, like, Stefan got me the Amber for 50 quid. £50, or it might even been $50, which is incredible. Try and find one of those for that price. So that was an amazing pickup. But then, the RAM was like £70 or something on its own, the fast RAM, and then I had to buy the chip RAM and all the melts and transistors not really transistors, because we took the only transistors off the original 500. And that's the other point. Some of the things were donated from the 500 motherboard, the original one. So you need a sacrificial donor for some of the stuff, your customs and things, but then you got all the 7.4 series, the melfs that I fitted here, all of the SMD parts, sockets, etc., connectors. You're looking easily £400 for the additional parts that I bought. So when you combine the £400 for the parts to the £300 for the case, that's £700, and then the motherboard, this, and any other bits that I'm forgetting about here, like power supply, for example. God, you can't be far off £1,000. Yeah. You can't be far off £1,000. Maybe £800 to £1,000 you're looking at for all the bits you need to get it all put together, if you can find everything you need. So is that good use of my money? No, it's not at all. And is it good use of my time? Well, I really thoroughly enjoyed building it. I enjoyed overcoming all the different small hiccups we had along the way, including the power LED. Yeah, that cost me a Gary. My own stupidity with that. But something's always going to go wrong. It's like when you're building something this complicated, you're going to make mistakes, and we had a few of those in this. And we had some unexpected things, like that chip popping out the socket on its own. That socket was perfect. There was nothing wrong with that socket. For no reason at all, when it got a bit warm, it ejected the chip. It was just one of those things. So we had lots of rework as I've gone through this. And as I mentioned a number of times through the series, the devil is in the detail, to quote Stephen Leary. It's like 95% of the time he spent on 5% of the issues. So the actual build, it didn't take a massive amount of time really, but the actual time to resolve all of the issues and get to this stage here, absolutely crazy. It's like almost as bad as Cather's A3000 5-part series from hell. There'll be a link top right to that. So yeah, I'm very pleased with it. I'm very proud of it, despite the fact it's a bit of a Frankenstein. The drive button doesn't come out here as far as it should, yeah? But when you put the disc in, it's perfectly usable. It's lined up perfectly there. You do have to press it in at that point, and then it does stand out, but you need fairly dainty fingers to eject it. We could change that, because I've got a bunch of different 500 drives here where the button is longer. And I just suspect it's one of those variants that was the style that was in here originally. So I'm not permanently stuck with that. But again, it's a feature of this that means something to me sentimentally, as everything in this build does. So this drive is the one that I spent like 10 hours on, and it was that video that's the floppy repair video, link top right, that I've had more views on than any of the other Amiga repair videos, because there were so many issues with that drive. And it still works perfectly to this day. I'll show you that. Let's boot test kit. Should boot. You can see the floppy LED now. Now it's powered with 12 volts as opposed to 5. There you go. Works perfectly now. And as you can see there, it booted up perfectly. And if I go to floppy drive, this is the thing, people watch my videos and they go, that's going to be unreliable. You'll have nothing but trouble with that. You'll be visiting that every 2 minutes. And I never am. I never have these issues. Because if you do something thoroughly enough, yeah, is it that one? I think it is. You'll always have reliability. You've just got to be thorough and make sure you do a proper job. And I think people think I don't do a proper job even when I bodge something. So like 10, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11, 11. I hope you get the idea. Yeah, just some more sentiment, to, you know, for me personally, that means, hang on, it just means something to me, that drive. So, you know, along with everything else in this, I just love it. And a quick look at Elite here. I'm going to have to talk over this because this music has now been copyrighted by someone on YouTube, because if you don't talk over it, it'll get copyright struck, which is ridiculous. I can't believe someone's copyrighted the music on this game. It's insane that someone would do that. If we just fast forward a little bit here to the point where it flies past the big Star Cruiser, you'll see how much the frame rate is so much better than a 500. See that there? It's so fluid compared to a 500. I do hope you've enjoyed this series. We haven't finished looking at this machine yet because we've got the daughter card, so huge thanks to Conrad. Thanks to everybody I've already mentioned in this video, Stefan and Sparks UK and various other people. But a huge thanks to Georg Braun for creating that PCB to start with, because if it wasn't for that PCB that Conrad sent me, I wouldn't have built it. If you did like the video, please smash the like button down below. Consider subscribing. You can support me on Ko-fi or Patreon. Every single dollar makes a huge difference to videos like this continuing on. I can't thank you well enough. Hope you have a good 2025. I'll catch you in the next video.